kind of tech-heavy engineering, mechanical design kind of class. And I'll run you guys through one of the first projects that I have the students do when they're getting going with 3D printers. Have any of you guys used a 3D printer before? Okay. Super easy to use. You basically design your file, which is the hard part, and then you pop it into the machine and hit go, and it goes for you. The printers themselves are pretty much foolproof. It's kind of the math and the design process that goes into it that can be a little bit more complicated. We'll talk about it here in a little bit, because you guys are going to kind of do a little bit of old school and a little bit of new school design. And hopefully some of you guys fail with your designs, because one of the things that I do is I really encourage my students to fail, and fail miserably and fail often, but they have to use that failure to learn from. So we really encourage growth mindset, which I'm sure all of you guys are grad students, you guys all know what that stuff is. But really encourage them to use failure as more of a learning tool and not necessarily a wall that's going to prevent them from going further. So if they screw up a design, they have to redesign it. If something happens to their file when it's 3D printing, which stuff happens all the time, they have to figure out why it happened and reprint it. If tolerances, which is how close maybe one circle is to another, or the size of a particular circle is off, go back and fix it and then reprint it. One of the things that we have the luxury of is a pretty nice budget for this particular class. So the laser cutter cuts in wood and acrylic, and the 3D printers print in plastics and resins, and that's stuff that we bring in on a very regular basis, just so that the students can have that failure experience. And I would say 95% of them do. They mess up on a pretty regular basis and have to go in and reprint. There's stuff all over the place. I have a couple of students that are in the process right now of figuring out what's wrong with that right-hand side MakerBot right there, because it's printing at a slant. And there's a couple of different things that it can be. I know what it is. They haven't quite gotten there yet. So when they figure it out, which will probably be tomorrow, they'll get it fixed and they'll get the prints going back in the right direction, where they're not kind of slanted at an angle like this. I think if we need to use that printer tonight, we'll still be fine, because our stuff's going to be fairly flat, fairly low resolution. So for us, it'll be just fine. It's when you start getting into some of the taller stuff. So we got some math teachers. Math teacher, math teacher, math teacher, science teacher, math teacher.
Language arts.
Language arts, okay. English, okay, and graduate assistants. Awesome. Okay. Language arts people, do you have math logical minds?
No.
No, okay, cool. Awesome.
I disagree with that. This is a very data-driven young woman sitting here.
Everything is very visual, and I'm going to walk you guys through everything that we're going to do up here. I get asked a lot kind of how we do some of the things that we do in here and how I grade things. And just to kind of give you guys a little bit of heads up, I'll be more than happy to go into it with you later. What you guys are going to do tonight is the first project the students do. When they come in August, they open up their computers, we play around with the CAD software, and I kind of set them free with this project. Every project that they do after that kind of builds on the previous project. So really, this class is more of a pass-fail class. The students all will eventually get to the same end. It's just how many trials and like redos and reprints and reprototyping they have to go through to get to that. Sometimes the students won't have an actual end product. I was telling Steve that earlier. Sometimes they have to actually describe to me why something went wrong, how it'll end up working in the end once all of the prototyping is done. And that suffices, because that shows understanding to me just as much as having a tangible piece does. With the current project, come hell or high water, they're all going to have a drone to fly once this whole project is done, which will be after spring break. We can talk a little bit about that. We can maybe go fly too. So you guys ever flown drones? Yes? Flown drones? No? Okay. We'll fly the big one. I don't have batteries in here for the big one. And I'll kind of tell you guys about that while you're working here in a little bit. So when they first come into class, my students have zero prior knowledge to any of the stuff that we're doing. They've never worked in CAD before. Most of them, their experience with any kind of Apple product is their phone or their iPad. They don't have Mac computers at home. Everything that we do in here is Mac-based. The original goal of this class was to be a design class, like a graphic design class. And like I said, it kind of took on a life of its own. We got 3D printers, then we got laser cutters, and it became engineering. So we've had to, typically that kind of design stuff is done on a PC, but luckily with the popularity of Macs, some of the software has been made available cross-platform. So we're able to do a lot of this stuff on the Macs, which in terms of computing performance and size of the computers, it's really nice because these are far more powerful than any laptop, PC version laptop would be when we got these. So it's all Mac-based. Are you guys Mac friendly? No, yes, kinda, sorta, okay. It's basically, when you're working on the Mac, one finger is gonna move the mouse, one finger is gonna click the mouse, two fingers on the trackpad is gonna be your right click, okay? And I don't know, there's really only one instance where you'll have to right click anything, and that's when we save our piece in the end. So what you guys are gonna be doing is you're gonna be making a piece of jewelry. You're gonna be making a ring to fit your finger, okay? And it can be as elaborate and ornate as you wanna make it, or it can be just a very simple donut for your finger. But you have to make it to where it custom fits your finger. Everybody's fingers are different sizes. And this is how students pass or fail their first project. Their first project, they have to print the ring, they design it, they print it, pull it off the build platform, put it on, walk to me and hold their hand like this. If it falls off of their finger, they've done something wrong. They need to go back and figure out where the issue was and redesign, which is very, very easy in this software because there's a timeline of history that you can go back through and fix things. It's not, you have to go and completely start back from scratch, and I'll show you guys that in a minute. If it only goes about this far, something's wrong, okay? So they have to go in and redesign it. If it comes out and it's not circular, something is wrong, and that's a printer issue. And that's where we'll work together and figure out what the printer issues are. A lot of times it has to do with the tensions of the belts. So not only are there students, I was telling you about that printer right there, it's a belt tension issue. The belt that's on the gear motor that's on the back of the printer, you can kind of see the two metal bands that are on it, is really, really loose right now. And they need to tighten everything up back there. So they become advocates for their own manufacturing. So they learn how to use everything, they learn how to troubleshoot everything. If they want to print a different color, they can print a different color. So until they print a ring that they put on and it stays on their finger like this, they keep going back and forth. And the great thing about these things is when you're just printing one of these at a time, it literally takes about 3 to 4 minutes to print off one ring. Now, if you're gonna make like Super Bowl champions from 2015 with all the little embellishments and stuff like that, that's gonna be another story. That's gonna take a lot of time. And that would be a process that would be better suited for the printer that's underneath the orange lid over there, because that is a really high resolution 3D printer. We're just gonna stick to the MakerBots right now because there's chemistry and stuff that goes along with that one that we'll talk about, but we're not gonna get into. We won't have time to. So you guys are gonna have to, with CAD software, you're gonna have to figure out how big your fingers are, okay? And in CAD software, you work in radius, like radii and diameters, okay? So you can't throw a circumference into CAD. Now, I've got a pair of calipers, and they're sitting back here on my desk, and that would be far too simple for you guys to just get a pair of calipers, measure your finger, or measure an existing ring, and figure out that the diameter of your finger is like 22 millimeters, and go and plug that into CAD and have your ring done in like 3 seconds. So what we do with my students is we discuss the importance of pi in math over time, and how pi is this perfect ratio to the circumference of a circle, all right? So what you guys are gonna do first is you're actually gonna figure out what the circumference of your circle is, and then you're gonna do the backwards math. So we've got some math people in here. So you know how pi relates to the circumference, right? Okay, so the circumference of the circle equals what? 2 pi r, or pi d, okay? So perfect. So we're gonna go with pi d because we wanna work with diameters when we're doing circles in CAD. If we're working with other shapes, then we would get into the radius of that particular shape. So you guys are gonna get C, and then for you math people, how do we figure out what the diameter is? Yeah, so you're gonna take pi and you're gonna divide it from both sides, so we get a little bit of basic algebra going on in here, some geometry going on, and then you're gonna have the diameter of your finger. Now, here's where a bunch of students go wrong with their rings. They don't need to know how to wash spray paint off their hands anymore. All right, so you've got, say, a 22.87 millimeter diameter finger, okay? And so you're gonna plug that shape into CAD, and you're gonna get this shape right here. Let's say you just wanna make a really simple, just cylindrical ring, all right? A bunch of students will come to me Mr. Hammer, that circle right there was 22.87 millimeters. I know it. I know that that was the diameter of it. It's like, okay, so tell me, we'll look at their model, and I'll get it up here on the computer in a minute, and tell me which circle on your model is this 22.87 millimeters. And so what they end up telling me, most of the time when they screw this up and have the correct measurement from the beginning, is that they offset their sketch the wrong way. And so they actually make what should be the inner diameter of their ring the outer diameter of their ring.